Okay, in this lesson, I'm going to teach you how to solve a common volume problem using a polynomial function. So let's get started by reading the example that I have here. It says, Angela is constructing a storage bin in the shape of a rectangular prism. The length of the storage bin is 1 more than the width, and the height of the bin is 1 meters less than twice the width of the bin. So there's quite a bit of information here about our prism. So there's two parts to my question here. The first part wants you to find a function that models the volume as a function of the width. Okay, so we want a volume function in terms of the width. Okay, so to find out what's happening with my other dimensions here, try drawing a diagram. Okay, so we have a rectangular prism. Okay, so just like that. And we have dimensions. So let's start with the length. So it says in my question here that the length of the storage bin is 1 more than the width. So here is my length right here. So since it's 1 more than the width, I can use an expression 1 plus w to represent the length. Okay, so let's move on to the height. The height of the bin is 1 less than twice the width. 1 less than twice the width. So if we go to our height, which is right here, height is 1 less than twice the width. So twice the width is represented using 2 times w, and we're going to subtract 1 since it's 1 less. So that is the height of my prism. And of course, the width is just w in this case here. Okay, so the volume function in terms of my w here is going to be my length times my width times my height. So my length expression is 1 plus w. Okay, and my width is going to be just w. Okay, and my height is 2w minus 1. So the whole idea is to produce a function in terms of one variable, which in this case is w. W represents the width. So there is my function that represents the volume in terms of the width. So we're going to move on to part B here. It says if the volume of the bin is 7.5 meters cubed, so they're given the volume here, determine the dimensions of the storage bin. So we know the volume, and we can use the volume function to find the dimensions. So go to your volume function right up here. And since we know what volume is, we're going to let V of W equals 7.5. And then we're going to proceed on to solve for W. Okay, so 7.5 is equal to 1 plus W times 2w minus 1. So there is my equation. I want to solve for w. Okay, so to solve a polynomial equation, I suggest using your calculator to do that. So go into your calculator. What you're going to graph here is each side of the equation. So 7.5 is going to represent your y1, and then this expression here is going to represent your y2. And what you're going to be looking for are the points of intersection between these two curves. So let's actually try to graph it first. Okay, so go to y equals, and you're going to graph 7.5 as your y1. And then in your y2, you're going to put 1 plus w. So we aren't going to use a w in my calculator. We're going to use a variable x. So 1 plus x times x times 2x minus 1. So in your function, you're going to let w be represented by x, since we can't put w's in the calculator. So we'll try a Zoom 6 standard for now. And we want to look at the point of intersection. So we have one point of intersection, and that occurs right there. So to find that point of intersection, you're going to use the intersect feature. So go second trace. Okay, and you're going to select 5 for intersect. So this option right here will give you the point of intersection between those two graphs. Okay, so I'm just going to delete that as well. Okay, so we want to find the point of intersection. So where you see your spider guy, you're going to put it to the left of the point of intersection on the first curve, and then you're going to press enter. And then it's going to ask you for a point on the second curve. So you want to get close and to the left of that point of intersection, and then you're going to press enter, and it's asking you guess. Press enter again, and it's going to give you a point of intersection at 1.5 and 7.5. So the answer that we're looking for here corresponds to the x value. So x is equal to 1.5, hence w is equal to 1.5. Remember, w was my width, so we know that the width is equal to 1.5 meters. So therefore, we have our width, but we still need to find the length and the height. So to find those two values, we go back to the expressions that represented length and height. And that came from our diagram. Here's my length, and here's my height. And we're going to use those two equations to find out what length and height are. So let's start with length. Length we know was 1 plus w. Okay, so since we know what w is, we plug it in. So 1 plus 1.5 gives me a value of 2.5 meters. Hence, that is the length. Okay, so far we have the width and we have the length, and our final dimension is going to be the height. So the height is represented using 2w minus 1. Okay, so 2w minus 1, we know what w is, it's 1.5, so plug it in. 2 times 1.5 minus 1 is going to give me a value of 2 meters. Okay, so there you go. There's my height value, there's my length value, and finally there's my width. And those are the dimensions of my rectangular prism. And that is how you solve a volume question using a polynomial function.